In an increasingly digital world, crimes leave behind digital footprints. These traces are often hidden within the vast expanse of data, waiting to be uncovered by skilled investigators. Windows OS forensics is the art of uncovering these traces. It involves a meticulous process of examining digital evidence, often requiring specialized tools and software. It's a captivating field, crucial for investigators and cybersecurity experts. These professionals work tirelessly to ensure that no digital stone is left unturned. This essay delves into the world of Windows forensics, revealing techniques used to analyze systems and solve digital crimes. From recovering deleted files to tracing unauthorized access, the methods are as varied as they are intricate. Imagine a computer as a crime scene. Just like in a physical crime scene, every detail matters. Every click, every download, every email leaves a trace. These digital footprints can tell a story, revealing the actions and intentions of the user. Forensic experts are like detectives, piecing together fragments of data to reconstruct events. They follow the digital breadcrumbs, connecting the dots to form a complete picture. Windows, being a dominant operating system, often becomes the focal point of these investigations. Its widespread use means that a significant amount of digital evidence is found on Windows systems. Understanding how data is stored and accessed is paramount. This knowledge allows forensic experts to retrieve crucial information that might otherwise be overlooked. This knowledge allows investigators to follow the digital breadcrumbs left by perpetrators. By analyzing these trails, they can uncover hidden connections and reveal the true extent of the crime. From identifying the culprit to understanding the scope of an attack, Windows forensics plays a vital role in our digital age. It is an indispensable tool in the fight against cybercrime, helping to bring perpetrators to justice and protect our digital world. Before diving into the depths of forensic analysis, one must grasp the fundamental architecture of Windows OS. Like a well-organized building, Windows operates on a layered design. Each layer serves a specific purpose, and understanding their interaction is key to successful forensic analysis. At the heart of the system lies the kernel, the core component responsible for managing system resources. It interacts directly with the hardware through the hardware abstraction layer, allowing Windows to function on diverse hardware configurations. Above the kernel resides user mode, where applications and user interactions occur. This separation of kernel and user mode ensures system stability and prevents applications from directly accessing critical system resources. Data within a Windows system is organized and stored using file systems. Think of these as vast libraries, meticulously cataloging every piece of information. Two primary file systems dominate the Windows landscape: FAT and NTFS. FAT, or File Allocation Table, is an older system known for its simplicity. It's like a basic library catalog, efficient for smaller storage devices but lacking the security and features of its successor, NTFS. NTFS, or New Technology File System, is the modern standard for Windows. It's a sophisticated system, akin to a high-tech library with advanced indexing, security features, and support for large files. For forensic investigators, NTFS offers a treasure trove of potential evidence. Timestamps, user access logs, and even deleted files can be recovered and analyzed. The Windows Registry is a goldmine of information for forensic investigators. It's a vast, hierarchical database that stores system settings, user preferences, and application configurations. Imagine it as a massive vault containing secrets about the system's past activities. Organized like a tree with keys, subkeys, and values, the registry holds clues about installed software, recently accessed files, and even internet browsing history. Forensic experts use specialized tools to navigate this labyrinthine structure and extract valuable artifacts. One such artifact is the Recent Docs key, which maintains a record of recently opened documents. Another is the Typed URLs key, revealing websites visited by the user. By carefully analyzing these and other registry entries, investigators can reconstruct user activities and uncover potential evidence. Section 5, Traces in Time Deciphering Event Logs. Windows. Event logs are like a system's diary, recording significant events and errors that occur. These logs provide a chronological account of system activities, invaluable for forensic investigations. Imagine trying to reconstruct a crime scene by analyzing security camera footage. Event logs offer a similar perspective, capturing user logins, application crashes, and file modifications. By scrutinizing these logs, investigators can identify suspicious activities, track an attacker's movements, and establish a timeline of events. Windows maintains various types of event logs, each serving a specific purpose. The system log records events related to system components, while the application log captures events triggered by applications. The security log, as its name suggests, logs security-related events like login attempts and access violations. Section 6. Tools of the Trade: Essential Utilities for Windows Forensics. Windows OS Forensics relies heavily on specialized tools and utilities. These tools act as extensions of an investigator's expertise, enabling them to delve deeper into the system and extract meaningful evidence. For file system analysis, tools like EnCase and FTK Imager allow investigators to create forensic images of hard drives, preserving the original data for analysis. These tools can recover deleted files, analyze file signatures, and even reconstruct timelines of file activity. Registry analysis tools like RegRipper and Registry Explorer provide a surgical approach to extracting valuable artifacts from the Windows registry. They can parse registry hives, decode binary data, and present the information in a human-readable format. Section 7. Case Study: Cracking the Ransomware Puzzle. Imagine a scenario where a company's network is held hostage by ransomware. The entire office is in chaos, with employees unable to access critical files and systems. The attackers have encrypted all the important data, leaving the company paralyzed. Files are encrypted, and the attackers demand a hefty ransom for the decryption key. The ransom note on the screen is a stark reminder of the gravity of the situation, often accompanied by a countdown timer adding to the pressure. This is where Windows OS Forensics comes into play, providing the tools and techniques to investigate the attack and potentially recover the encrypted data. Forensic experts utilize specialized software to dissect the ransomware's behavior and trace its origins. Forensic experts would begin by creating forensic images of affected systems, ensuring the preservation of evidence. This step is crucial as it allows investigators to analyze the data without altering the original state of the compromised systems. Analyzing event logs might reveal suspicious login attempts or unauthorized software installations, providing clues about the initial infection vector. These logs can be a goldmine of information, showing exactly when and how the attackers infiltrated the network. By examining file system timestamps, investigators can pinpoint the exact time of encryption and potentially identify the ransomware variant used. This information is vital for understanding the scope of the attack and planning the next steps in the response. Analyzing registry keys related to recently executed files or network connections might reveal further details about the attacker's actions. These keys can show what programs were run, what files were accessed, and even what network connections were made, painting a comprehensive picture of the attack. Section 8. The human element: intuition meets technology. While powerful tools are essential, Windows OS Forensics is not just about technical prowess. It requires a blend of technical expertise and investigative intuition. Experienced investigators develop a keen eye for spotting anomalies and connecting the dots. Analyzing raw data alone is rarely sufficient. Investigators must interpret the findings within the context of the investigation, considering user behavior, motives, and potential cover-up attempts. This is where human intuition, combined with a deep understanding of Windows OS, becomes invaluable. The ability to think like an attacker, anticipate their moves, and unravel their techniques is crucial for successful forensic analysis. It's a constant cat-and-mouse game, where investigators must stay one step ahead of increasingly sophisticated cybercriminals. Section 9. Conclusion: Windows OS Forensics, a vital tool in the digital age. As our reliance on technology deepens, so does the importance of Windows OS Forensics. In today's interconnected world, every click, every transaction, and every piece of data leaves a digital footprint. From solving cybercrimes to investigating data breaches, this field plays a critical role in maintaining digital security and justice. The ability to trace these digital footprints can mean the difference between catching a cybercriminal and letting them slip through the cracks. Understanding the intricacies of Windows OS, mastering forensic tools, and knowing how to interpret the data are crucial skills. Cultivating investigative intuition and analytical thinking are essential for success in this field. It's not just about the tools, but also about the mindset and approach. As technology evolves, so will the methods and techniques employed by forensic experts. Staying ahead of cybercriminals requires constant innovation and adaptation. Continuous learning and adaptation are paramount in this ever-changing landscape. Professionals must stay updated with the latest advancements and continuously hone their skills. Windows OS forensics is more than just a technical discipline, it's a blend of science and art. It's a quest for digital truth, a meticulous process of uncovering hidden data and piecing together the puzzle. A pursuit of justice in the digital realm, ensuring that those who exploit technology for malicious purposes are held accountable. As long as digital crimes exist, the need for skilled forensic investigators will continue to grow. Their expertise is indispensable in the fight against cybercrime, ensuring a safer and more secure digital future for everyone. The role of Windows OS forensics will only become more critical as our digital landscape continues to expand.